In this video, we are going to be looking at acid-base titration, different aspects of acid-base titration. So let's begin. I'm going to start with definition of some terms, in acid-base titration. The first is qualitative analysis. Qualitative analysis is a branch of chemistry that deals with the determination of the amount or percentage of one or more constituents of a sample. Okay, so in quantitative analysis, we are interested in determining the amount of substance in a sample. Okay, then we see titration. Titration is also called titrimetry. Titrimetry. You can also call it volumetric. Titration can also be called volumetric analysis. Okay, so here it says a titration is a technique where a solution of known concentration is used to determine the concentration of an unknown solution. Okay, but in this particular lesson, we are going to be interested in just one, which is acid-base titration. There are others, but we are interested in acid-base titration. Okay, then we see the word standardization. What is standardization? It is a process of determining the exact concentration, which is molarity, of a solution. Titration is one type of analytical procedure often used in standardization. That's one of them. In a titration, an exact volume of one substance is reacted with a known amount of another substance, for we to find the exact concentration. So that leads us to standard solution. What is a standard solution? The standard solution is a solution whose concentration is known. So when you are about to titrate, maybe acid or base, sometimes the concentration of the acid is known, sometimes the concentration of the base is known. That is called a standard solution. A known mass of solute is dissolved to make a specific volume. It is prepared using a standard substance, such as a primary standard. So that means the substance we use to produce a standard solution is what we call a primary standard. Okay? So here we look at primary standard. What is primary standard? Primary standard is a substance that is used to prepare a standard solution. Okay? It's used to prepare a standard solution and must have the following properties. Okay, number one, it is extremely pure. Number two, it is stable to heat. It's not something that decomposes easily when heated. Number three, it has no water of crystallization. Okay. Number four, it has high molecular weight. Okay. Number five, it is inexpensive. You can easily get it. Number six, it is not deliquescent or hygroscopic. Number seven, it has low toxicity, not poisonous. Number eight, or little poisonous. Number eight, it is readily available. Number nine, it is not very reactive. A primary standard is something that is not very reactive. Number 10, example is sodium trioxocarbonate 4. That is one major example of a primary standard solution. Now we also have a secondary standard solution. But a secondary standard solution in a chemical term is referred to a solution that has its concentration measured by titration with a primary standard solution. That means when titrating what you titrate against a primary standard is what we call a secondary standard. Okay, that is important for us to note. So we go to another, which is indicator. What is an indicator? Indicator is any substance that changes color whenever there is a change in pH of its medium. So any substance that changes color in acid or base medium, that substance is called an indicator. And if you look at this table, there are many indicators, but commonly used are these three that I've written here in the table: the litmus, methyl orange, and phenolphthalein. Okay, so let's quickly run that through. The pH range for litmus is between 5.0 to 8.0. The pH range for methyl orange is between 3.2 to 4.4. The pH range for phenolphthalein is between 8.2 to 10.0. So the original colors, litmus is purple. Or you can use the word color in a neutral medium. Litmus is purple, methyl orange is orange, phenolphthalein is pale pink. Okay, but in acidic medium, litmus is red in color, because remember, litmus turn blue, litmus red, or acid turn blue, litmus red. In methyl orange, it is red. In phenolphthalein, it is colorless. Okay, then in basic medium, for litmus is blue color in basic medium. Methyl orange is yellow color in basic medium. Phenolphthalein is pink color in basic medium. Okay, so the next we're going to look at is suitable indicators for titration. These indicators are actually used during titration. So we have strong acid. When you're titrating a strong acid against a strong base, we can use any indicator. Okay, we can use any indicator, any of them. Now, but when we are titrating strong acid against weak base, a strong acid against weak base, what we use is methyl orange. Okay, but when you're titrating a weak acid against strong base, the indicator used is phenolphthalein. We use phenolphthalein in that. Then weak acid versus weak base. Here there is no suitable indicator. When you are titrating a weak acid versus weak base, there is no suitable indicator. So please note that. Now, these are examples of strong acids, so that we know. You have HCl, you have H2SO4, you have HNO3. Okay, that's hydrochloric acid, sulfuric acid, and nitric acid. Okay, then see examples of weak acids. You have H2CO3, that's carbonic acid. You have H3PO4, that's phosphoric acid. We have CH3COOH, that's ethanoic acid. We have C2H2O4, that's oxalic acid, or what you call ethane dioic acid. Those are examples of weak acid, and they should be taken note of. Okay, strong bases, we have just two strong bases. We have potassium hydroxide and we have sodium hydroxide. These are strong bases. Then the rest are weak bases, of course. We have ammonia, or what we call ammonia solution, aqueous ammonia. We have calcium hydroxide. In fact, the rest are bases: magnesium hydroxide, sodium carbonate. Now, don't forget that bases are metallic oxide or metallic hydroxide. So I can even still add things like zinc oxide. I can add things like calcium oxide, silver oxide, and so on and so forth. They are all bases, but they are all weak bases. We have only two strong bases, which is sodium hydroxide and potassium hydroxide. Okay, so here we see that the suitable indicator for titrating H3PO4 and NaOH is phenolphthalein. Why? Because H3PO4 is a weak acid, sodium hydroxide is a strong base, and the best indicator to use when you are titrating a weak acid versus strong base is phenolphthalein. I want to believe that that is clear. Okay. Now, the next we're going to look at here is what we call a universal indicator. What is a universal indicator? It is a mixture of dyes. Note that it's a mixture of different dyes that changes color gradually over a range of pH and is used, especially as indicator paper, in testing for acid and alkalis. So there is a color range. In this study, I'm not interested in showing you the range of color, but it can measure all ranges of color, okay, from 0 to 1, and the color just keeps changing depending on the pH of the solution. Now, but I want to add some definitions here. With two things I didn't write down. We have endpoint. You should know what endpoint is, and you should know the difference between endpoint and equivalence point. Equivalence point. So what is endpoint and what is equivalence point? Okay, so the let me start with equivalent point. Equivalent point is the point when the chemical reaction comes to an end. Once the neutralization reaction comes to an end, we call it the end equivalent point. The equivalent point is a point when the neutralization reaction comes to an end. Now, but the end point is the point where color changes in the system. So that point where the color changes is called the end point. But the end point is not necessarily the equivalent point. In the equivalent point, neutralization is complete, but in the end point is when there is color changes, when you observe a color change. Okay. I want to quickly get a table that will help us differentiate between endpoint and equivalent point. But that is the major definition or major difference between endpoint and equivalence point. So please, let's take notes. Okay, we move. So let's see. This is calculation in preparation of solution. Okay, I was